My name is Kirstyn Johnson, and I will be presenting projectile motion. So, to begin the slide, we must define projectile motion. I define projectile motion as when an object is in motion caused by a force acting upon it or gravity, then causing it to become a projectile. Typically, you would want to assume that there is no air resistance. As far as breaking down the definition of projectile motion, first, a projectile would be an object either tossed, falling, or flying through the air. Simply put, an object in the air. Motion is simply the state of moving, not being stationary. So for two examples, a cannonball shooting out of a cannon is a projectile motion. It has both kinetic and potential energy as it is gradually increasing in kinetic energy and decreasing in potential energy as it reaches maximum height. And then motion, people simply dancing is moving, but of course you would not consider people dancing as a projectile, but the cannonball flying through the air is. How does an object become a projectile? That would be due to the force acting upon it. As stated previously, an object would become a projectile when a force acts upon it. That force can be a push, gravity, or acceleration itself. For a few examples, when a ball is rolling or a car is driving, these objects are in motion, but they are not yet a projectile because there is no force acting upon it. If a ball were to fall off the table, then it would become a projectile as the force of gravity is pulling it downward towards the floor. Now, similar to that same example, if someone were to throw a basketball towards a hoop, that is an upward motion causing that ball to become an upward projectile due to the push force of that person's hands. In these two statements, the ball is a projectile in both, but in the first example, it is a downward projectile, and in the second example, it is an upward projectile. I'll explain that later as I go on with the presentation. For shape of trajectory of a projectile object, of course, as a force acts upon it, it will remain at a constant velocity in the x direction, but change in velocity for the y direction. As a projectile object rises, the kinetic energy increases while the potential energy decreases. This is due because as it is rising, it is reaching maximum height with that velocity and acceleration, but it is getting faster in motion, being the kinetic energy, and less potential energy since it is no longer stable as it previously was from the initial velocity. As a projectile object falls, this kinetic energy now decreases while the potential energy increases. This is of course because it is losing that energy, now falling, leaving its maximum height, and the potential energy increases because it is slowly going to reach the ground, gradually coming to a stop. Now, as far as formulas and equations related to projectiles, these are very important because this will help you determine all the variables and unknowns that you need for your equation problem or future questions. But first, to start off, the variables. Variables are very important for projectile motion as they follow. A v means velocity. Vx means horizontal velocity along the x-axis. Vy would be vertical velocity along the y-axis. Now that's like the Vx will be the distance your object is going, traveling, and then the y would be the height that projectile is at while traveling. A is the angle of the projectile. That is very important as far as the initial velocity goes as well, because that will help you determine things as far as time, range, height, so on and so forth. It's very important to find the angle at which it was either going up into the air or falling down, such as the ball rolling off of a table example. H is initial height. That's also very important because is the ball falling from a table? Is it falling from a child's hand? Or is it falling from the top of a building? That will play its part into the equation and solving that problem. T is time. That's also important because you want to know, is that ball rolling off the table for 2 seconds? Or is it rolling down a hill for like 20 minutes? Distance or range of the projectile. Once again, that's going to be similar in a way to the horizontal velocity, because you have to have how fast it's traveling horizontally combined with what is that distance that it is traveling. And then H max is the maximum height. That is as much as that projectile can travel along the vertical axis before reaching its final stop at the final velocity. Formulas and equations related to projectiles go as follows. These are going to be similar to your textbook or formula sheet for the test, but here's a couple to go over. When you're trying to find time, you want t square root of 2 delta y over a. So that way you have your vertical distance over the angle. And then also to find the time to reach maximum height, you would have Tm, also time, but that way you can defer between the two, with the velocity sine over g. G typically being 9.8 or 9.81. When determining final velocity, you want the horizontal and vertical velocity squared, added, but then square rooted. To find maximum height, it is a longer equation with those same variables, or you can also do it with h that way as well, with sine correlating to the horizontal. To find range, it can go both ways with either the x or the y. Sine will correlate to the vertical. I correct myself on my previous statement. And cosine will correlate to the horizontal. So those two equations at the top there will be used when you're determining an upward projectile, and the bottom two will be determined the range for a downward projectile, similar to the two examples I gave previously for that reason. Now, with those variables and equations in mind, you would have to apply that to figure out how to determine each variable for a projectile in motion. For example, my problem for everyone to solve is a cannonball is shot out of a cannon at an angle of 40 degrees. It is traveling horizontally at 22 meters per second. From the first shot to the final landing, the total time the cannonball was airborne for is 2.9 seconds. Now, you must determine the range of the cannonball. I put a hint in here because this is a two-step equation. That way you would have to find the initial velocity in order to find the range. Take note of the given quantities that I provided and use your equations wisely. Use all of this information to find the range. And of course, remember, once you find the initial velocity, you then have to plug that into the appropriate equation in order to determine the range. So there are those two unknowns that you will have to determine. Good luck, and let me know